Good morning, folks. That's better. Hopefully you had a great day yesterday, and we are ready for another great day. We have a great speaker this morning. So first we are going to hear David Woessner of Local Motors. He's the general manager at Local Motors, and it's a new company challenging other automotive companies, and I think they have a great story and you will enjoy it. And after his talk, we are going to have a panel discussion with the 4 other industry executives. So with that, let me invite David to the stage.
Thank you. Good morning. Guten Morgen. Yeah. So most of you couldn't tell, but I'm actually German. So thank you, Andy, for hosting this event and having us here. Excited to be here. As Andy said, I'm David Woessner, or for my American friends, Dave Woessner. So I'll talk a little bit about Local Motors and what we're doing, but I'll start off with, oops. Who remembers this? All right. Hated dialing, 917 area codes, like 9, it just took forever. And so we kind of remember this. Some of your kids or grandkids in here probably don't remember this, right? But what happened? It took really roughly 100 years to go from that to what everyone has now, which is probably a Android or iPhone-based smartphone. So I always like to do this. This crowd might be a little funner than other crowds. How many of you still have flip phones? No? Wow. Normally I at least get one brave soul to admit that they're the Andrew Luck of this room. So if you know Andrew Luck of the Indianapolis Colts, I went to school at Wabash College in Crawfordsville, Indiana, so I'm a big Colts fan. But Andrew Luck still has a flip phone, so I'm surprised that no one will be honest enough to admit that they are still rocking a Motorola flip phone in here. So anyway, but it took about 100 years to make that really gigantic leap in innovation from what we used to know as a rotary phone to what we all now are accustomed to as having basically a supercomputer in our pocket to get us anything and everything that we want and even talk to us. Well, for our industry that we're in as Local Motors, really the last 100 years haven't really changed from the way we design, build, and sell vehicles. Henry Ford did us all a great favor and invented the assembly line in the early 1900s and started producing Model Ts. And right, what could you do? You could have any Model T as long as it was black. And really, today, besides the fact that you get some more options and color combinations and model types, vehicles are really built and sold the same way. And so fundamentally what Local Motors is about is looking at how do we not just incrementally change what is happening. I would argue that Tesla is incrementally changing the traditional way to design and build vehicles. They just are much better than some of the original players in putting really good technology into the vehicle and making it sexy. But fundamentally, they still have a big factory out in California where it's very capital intensive. It's pretty environmentally unfriendly to make a vehicle. But don't take my word for it. John McElroy, who's a respected automotive journalist, wrote this about 5 months ago after he interviewed Justin Fishkin, our Chief Strategy Officer. And so let me talk a little bit about how we really are approaching disruption.
This is the end. The end of the assembly line. The end of the showroom floor. The end of the smooth-talking salesman. The hard sell. The soft sell. The oversized inflatable gorillas and overinflated inventory that absolutely must go. This is the end of the junkyard full of old cars, leaching chemicals into the ground. Born from the concept of cradle-to-cradle manufacturing. Printed in front of you to be the exact car you want. Melted, deconstructed, and rebuilt to be the next car you need. This is where vehicle manufacturing as we know it comes to an end. And where vehicle manufacturing, as it should be, begins.
So we are Local Motors, but our name doesn't say it all, right? You would think that we make cars, but we don't just make cars. We design, build, and sell vehicles, and we exist to really shape the future in a way that has never been shaped before. We want to make the world a better place through hardware. And I think I just had a conversation with one of my fellow speakers, is some people are struggling with getting talent who still want to make things, right? A lot of people want to go and make the next great app, like Facebook or Instagram or something like that. But we actually care about making things in this country and making forward-thinking products that will benefit humanity. So our process is really a process of co-creation and micro-manufacturing, and I'll talk about both those. The one thing I'll invite everyone to do here is join us in that effort, because we actually use an open platform to do vehicle innovation and vehicle development. So if you want to find out more, you can go to localmotors.com and do so. Why did Jay Rogers, our CEO and co-founder, start with the vehicle? Well, because and a lot of you are in industrial companies and working on complex industrial systems. But what I would argue and what we would argue is that fundamentally the vehicle is the most complex system there is. Between design, engineering, production, supply chain, sales, and service, it is a pretty complex system. So we thought if we could disrupt that system, we can disrupt any system out there. Plus, it's a pretty healthy and sizable industry. Some people talk about it's a $2 trillion industry. Annually, you get about 100 million cars made a year. $20,000 is the average transaction price. You get to $2 trillion. If you now start thinking about what Adam Jonas at Morgan Stanley talks about is the cost per mile. Annually, about $10 trillion miles are driven on the roads around the world. And if you value each mile at around $1 a mile, you'll get to around $10 trillion. So it's a significant, sizable industry that we're talking about trying to disrupt. Jay Rogers was serving as a Marine in Iraq and realized that we were fighting a war for our dependence on foreign oil over various resources. So he wanted to create a company that would focus on not how to deplete resources, but how to actually be sustainable with the resources that we have. The second thing is, and this was taken about 2 years ago on a Hero motorcycle in India, it's the vehicles that he was being deployed in Iraq were built and designed 30 and 40 years ago and were not fit for purpose anymore. And so he wanted to create a company that really focused on the safety and making it affordable to get safe vehicles and safe mobility to all corners of the world. So he believed in this obligation to be great, and that's when he created Local Motors at the beginning of 2005 when he joined Harvard Business School and started developing the business case and the business model over the next 2 years, and Local Motors got incorporated in 2007 right outside of Boston, Massachusetts. How many of you still drive cars in here? Don't be shy. Okay, the majority. What's the average componentry and parts in your vehicle today? This is the interactive part. 4,000, 14,000, 10,000. Anybody else? It's roughly 20 to 25,000 components. And if you have a gas-powered vehicle, which most of us probably still do here, the powertrain itself is about 8,000 components. So it's a lot of complexity just in the vehicle itself. It needs global supply chains to go and put together. This is a replica or blowout of the original 3D printed car that we printed around 2.5 years ago at IMTS in Chicago. Some of you may have been there and seen this event because it was a little bit world-changing. It was the first time ever that a 3D printed car was printed and then assembled and driven within a matter of 45 hours of starting the process. How many components do you think that has? Again, this is the interactive part. I know it's early in the morning. 50, you read our website, that's okay. So we have around 50 to 75 components. It depends on the options that we put together. But the point is, if you fix that complexity of taking, a vehicle with 20 to 25,000 components, and the fact that now you add in the consumer electronics pieces and the 20 to 25 million lines of code, having a vehicle with 50 components that you can print in a factory of 50,000 square feet can help you create local supply chains and local manufacturing. And so that's what our focus has been. So Jay and our team went back to the drawing board, and we really believe in co-creation. So this is the original co-created vehicle that was the Rally Fighter, which we developed in 2008. It's a little bit of a Frankenstein of a vehicle, right? It has Civic taillights and a Hyundai ignition and a Chevy motor. But the point was, we took the best of what's out there in the market. We asked people around the world, our community of about 60,000 co-creators across about 140 countries, to give it their best shot and make a vehicle that was really a street-legal desert racer. And so this is a collage of all the people that contributed to that vehicle in a co-creation process. And we do that for each one of our vehicles. So the one that we've now gotten a lot of attention over in the last 6 to 7 months is actually the Ollie. And so that's the top left corner that you're looking at. That's a 22-year-old at the time industrial designer that was studying in Italy and is from Colombia. And he won that challenge, that was the Urban Mobility Challenge in 2015. And he got paid a fee for winning the challenge. And then when we produced the first 2 Ollies, he got a royalty check. So there's a way that as a part of our community, you not only get recognition and build your portfolio, but you get remuneration and you get actual money. The other part of our platform is micro-manufacturing. So again, interactive. What do you think the average size of a traditional automotive plant is? Say it again, be a little louder. 50 acres. Okay, you can put an apartment building on that, but the average size of a factory in the United States is between 1 and 2 million square feet on anywhere from 700 to 2,000 acres. So if you go to Spartanburg, South Carolina, where BMW makes all of its X vehicles, it's probably 4.4 million square feet on 2,000 acres. And it's a juggernaut for the South Carolina economy, right? If you've been to Greenville lately, over the last 20 years, that has really developed. If you go to Hyundai's plant in Ulsan, South Korea, they produce 2 million vehicles a year there, one spitting off the line every 45 seconds. If you go to Montgomery, Alabama, and go to the Hyundai plant down there, or Kia in West Georgia, they're representing anywhere from 2 to 5% of the state's GDP in just that one facility. So it's a great economic engine. The issue is, how many of you have been in Detroit lately? No Detroit visitors. Oh my goodness, we got to get you to Detroit. So I used to work for the mayor of Detroit. Detroit in the 40s and 50s was the economic juggernaut of the United States. Well, what happened in the downturn over the last 5-6 decades, a lot of those great factories have now been what some people call ruin porn, right? And they're really like just eyesores in the city of Detroit. So if you have a big footprint to make vehicles, it's great in good times, but if it's also very capital intensive, and every time you put a new paint shop in one of these factories, it's probably $800 million. So what happens if it doesn't get used anymore? Well, it just sits there because it's hard to repurpose 2,000 acres and 1.5 to 2 million square feet. Our microfactories are here to think big, but never by feeling big. So our standard footprint is really only about 50,000 square feet on 10 acres. And our factory will never make 1 million of something. We target to make about 1,000 to 3,000 vehicles a year. So again, the point of we don't just want to be innovators, we also want to be manufacturers. And we don't want to just create prototypes. We want to actually make vehicles that are locally relevant at each factory. And so this is our factory down in Knoxville, Tennessee, right adjacent to the Oak Ridge National Lab, where we do a lot of materials development. And it's really the digital factory of the future. And in a later session, I'll talk a little bit more about that. So that's my plug for seeing me later in track 5 to really learn what the digital factory of the future looks like. Again, from a digitization process, we work with a lot of organizations to make the products more digital and have a direct digital thread from design, development, all the way to manufacturing to be able to go with as little tooling as possible from a concept to a finished product. And so our process between co-creation and micro-manufacturing has been proven. So the dark blue bars, I won't name who those OEMs are other OEMs, and the amount of days it took them to go from concept to production ready. Actually, from concept to the 25th car of that vehicle series, the amount of capital they spent on it and how many people were engaged. So what you see us in being the light blue, we do it a lot faster at a lot less capital, but we use a lot more people. So how many of you were at IMTS in Chicago in 2014? Okay, 2 of you, 3, 4. Some of you may have seen when we did this the first time. So we 3D printed the Strati in Chicago. And here's a time lapse of that video, of that happening. Oops, did it work? Nope, sorry. The video's not gonna play, so I apologize. But we did that in about 44 hours. Oh, you're working on it? There we go. So this is a time lapse. So thanks, Alan, for saving me there. So that was a time lapse of about 45 hours to print that vehicle. When we first started this process with Oak Ridge National Lab in 2014, it took roughly 160 hours to do that. And by September of 2014, we were down to 44 hours. Right now, we're at the point where we're printing that in around 18 to 20 hours. And the other thing that we're doing, the unibody that is the Strati weighs around 1,100 pounds. We've now figured out to using carbon fiber reinforced plastic and some different polymers to get it take about 450 pounds out of weight out of there without compromising some of the strength in the material. So the advances that we're doing in this direct digital additive and subtractive process over just the last 3 years in collaboration with Oak Ridge and IACME, one of the Manufacturing USA institutes, have been tremendous. And then in January of 2015, we kind of said, look, we don't just want to make a toy out of the Strati. We want to actually prove that down the line we can have a highway certified vehicle. So we developed what is called the first of the LM3D series, the SWIM, that we revealed at the SEMA show in 2015. And this was our first step into getting to a highway car. And so the point is, right, the ability to use a platform, a skateboard of an electric powertrain and battery combination, and then very rapidly iterate on what the body looks like. So You see the one is kind of a beach buggy, but then also a sports car. And so that's the point of being able to be highly configurable on a small footprint without having to change any of the tooling or the actual processes from a manufacturing perspective. So we don't just do this for ourselves. So we as a community of co-creators and then a network of microfactories create vehicles for local motors. But we also have tapped giants like Airbus and Siemens and GE to work with them in our community to create products. With GE, we've done appliances. With Airbus, we actually just created a cargo drone last year that took its maiden voyage from concept to prototype in less than 3 months. And we revealed that in the Thanksgiving timeframe. So the overall goal of this process is to take what a traditional automotive OEM would look at as a very complex value chain and a very long development cycle. Normally, the average to go from concept to production ready for a traditional OEM is anywhere from 5 to 7 years. What we've tried to do is really consolidate the value chain. We're bringing raw material back into factories, similarly to what Henry Ford first did in the early days of the Ford Rouge plant. We're going direct to customers, so factory direct, and then our goal is to go from concept to production ready in less than 6 months. We're not quite there yet. We're closer still to 2 years, but that's still a significant improvement from 5 to 7 years. Again, the point is to be able to take hardware and iterate at the speed of what people are used to from software. So with your iPhone, right, you get software updates on a probably daily basis to your apps. And then you get iOS or operating updates every 3 to 4 months, and then you update your hardware every 18 to 24 months. That's the future of what we're looking at from a vehicle system, is that we're able to upgrade on a hardware basis every 18 to 24 months to get you the latest hardware into your vehicles. One of those innovations is what we revealed, and I'll spend the last 2 to 3 minutes on this, what we revealed at our grand opening in National Harbor, Maryland, right outside of Washington, D.C. We introduced the Ollie, which is a self-driving, low-speed electric multi-passenger vehicle that is actually cognitive enabled using IBM Watson. So it enhances the rider experience because you don't have a driver, so you can't talk to anybody if you need restaurant suggestions or want to understand what locally is happening. You can actually interact with Watson, and they can tell you how the weather's going to be later today, where you may want to catch dinner around here, and things like that. So it's cognitively enabled. But it's more than just a vehicle. We actually sell an ecosystem, or we allow people to subscribe to an ecosystem. So there's an initiation piece, there's supervision, remote supervision of the fleet of vehicles that are operating. We have fleet management and obviously cloud analytics to be able to be responsive to the operating environment of the vehicles. The other thing is, right now we're operating a pilot in Berlin, Germany, in collaboration with Deutsche Bahn and the Transport Ministry of Germany, where it's actually operating on a fixed route, so similar to how most of us would catch a bus today. People can jump on the vehicle and experience a self-driving, operator-less vehicle, so to speak. But in the future, we'll also have waypoint and on-demand capability. The other piece of the vehicles, it's really adaptable, right? And so it can be for passenger in a first, last mile park circulator kind of activity. So you could see yourself around the Disney parks, for example, to go from the parking lot to the front of the park. There's also logistics applications for parcel delivery potentially, and a variety of others. So we're not too far from Richmond, Virginia, up in National Harbor, and I had Capital One Bank in our facility, and they thought, well, could we turn this into an ATM on wheels? And so there's all kinds of other applications. Now, granted, in the future, we may never need cash anymore, but in the case you still need cash, the vehicle could come to you. Again, I'm from Detroit, and so I wanted to give a quick example of what it could be applied for in a diverse city like Detroit. Detroit is actually went from 1.9 million residents in the 1950s to about 700,000 today, but the square mileage is actually as gigantic as it has always been. It's around 140 square miles. So you have very low dense areas that are underserved from a public transport mode. So having a connector like an alley to go represent and serve underrepresented areas or low density areas and then connect them with main transit lines is one way of how to use this as a first last mile solution. The other one is, most of you have probably heard that Detroit is Gilbert land, right? So Dan Gilbert, the owner of the Cavs and founder of Quicken Loans, has actually contributed a significant amount of money to creating a streetcar, which is called the Q line, but it goes from Midtown all the way to downtown. Dan Gilbert, for example, has 15,000 employees in downtown, and there's not a lot of parking available. So just at the northern part of Wayne State, there's actually, just past that, there's a parking lot where some of his employees get shuttled to. That part in Detroit is not a very walkable part. Plus, in the winter, it's a disastrous part and pretty icy. So even though it's only about 1,000 yards, you don't want your employees necessarily to walk that. So one approach is to have a shuttle operating between the parking lot and the last stop on the Q line to get people from Midtown to downtown. And so it's an enhancement of this multimodal transportation system. So,
Detroit, Houston, we have a problem. A problem with more. Every second, car companies put more cars on the road. And as they do, more end up in junkyards, leaching chemicals into the ground. But what if there was a car company that said no more to more? That started by building cars with one of these, not in one of these. And only when you needed one. So car lots looked a lot more like this, not that. Then, come trade-in time, they literally turned your old car into your next car. Maybe then we could slow that number down, more and more, just by doing what no car company ever has, strive for less.
So we're inspired by cradle-to-cradle manufacturing and the ability to make safe, smart, and sustainable vehicles. And so our future looks like a combination of vehicles that are multi-passenger, shared mobility, low speed, with an ability to go and repurpose materials of existing vehicles to make new vehicles. And so that's what we're here to do and try to disrupt the biggest system of them all. Thank you very much.